In order to make a good choice and use most effectively ASP.NET MVC, it's important to understand how the MVC pattern actually works with the framework and how that's going to be different from your other major choice, which is ASP.NET Web Forms. So MVC stands for Model View Controller. And I want to point out that it's an application design pattern, not a Microsoft tool. The MVC pattern has been used in creating applications in a number of different languages and frameworks. But Microsoft has just created its own implementation of the MVC pattern in a framework to make it easier for you to build applications using this pattern. So once again, I want to point out that this pattern has been implemented in other frameworks and other languages, but ASP.NET MVC is Microsoft's implementation of the MVC pattern. So if you're in a job interview and somebody asks you about MVC, don't go riding off talking about ASP.NET MVC, because that may not be what they're wanting to hear from you. I also want to point out that it's an alternative choice alongside web forms. It's not a superseding technology. So just because ASP.NET MVC is newer for Microsoft, that doesn't mean that it's the next evolution of web forms or that everybody should try to convert all their web forms apps over to MVC apps. That's not the case. What they wanted to do, though, is they wanted to give you another option alongside web forms. So if the MVC framework fits your development needs more than web forms do, you have that option available. But web forms aren't going away anytime soon. In order to really understand how this pattern is implemented by the .NET MVC framework, I want to talk about the architecture behind it. First of all, the M stands for model, and this is the representation of your application data, and usually this is in the form of domain classes. It doesn't necessarily have to be that way, but it's one of the more common ways to do it. So just for right now, if you think about the model, you might think about your data or the programming representation of your data. And then the V is for view. This is going to be what presents data to the user. This is your user interface. It's usually HTML. And typically, you're going to have little bits of programming snippets in there, but they're all revolving around stuff to display and how to display them. It's not actually hitting a database or anything like that. And then finally, we have the C, which is the controller. And the controller's job is to receive requests. Okay, so the user types in something into the address bar. And what the controller does is it takes that URL and uses it to figure out what the right model is, what the right view is, and it smushes them together. And it does any other necessary programming logic that might have to occur. So the controller kind of serves as the traffic cop. It helps serve up and communicate between your model and your view, and it's the URL that tells it what to do. So a really slick-looking diagram of this is right here. And you can see the way the architecture works. The HTTP request, okay, that's the URL. Somebody clicks a link or somebody types it into the address bar. It comes to the web server. The controller reads it and then uses that URL to figure out what to do with the model. So it pulls up the model. The model may come from persistent storage like a database. That model then gets put into the controller. The controller works any magic on it that needs to be worked. And then it puts it together with a view, and that view, that end result, becomes the HTML response that gets sent back to the server. Now notice this model is different than your web forms model, where you have something like a view, but it's tightly coupled to a code behind file. And also that view is more like a web page. You put in the HTTP request and you get that web page back and it processes the code in the code behind file. But you'll notice here the architecture is kind of built around the controller. The controller is listening for the URL. The controller figures out what model it needs and what to do with it. The controller figures out the view. And so the controller is really the centerpiece of this architecture, and that's why there's no code behind files, and that's why there's no direct tight coupling between, say, a particular web page and its code behind. I want to take a quick look at the structure of an MVC application just to relate it to the architectural pattern. So I'm not going to get very deep into how each individual piece works, but I want you to see how the different areas of the application tie to the architecture. So when I look at the MVC application, and this is just the default MVC application that Visual Studio uses when you start up an MVC project. You'll notice I've got a folder for the views, a folder for the models, and a folder for the controller. Now when I actually start this project up, okay, get a nice pretty page here, and you'll notice as I move around, like here's the About page and here's the Contact page, check out these URLs up here. I'm not pointing to a specific file like a .html or a .aspx or a .asp page. I'm just generating URLs. Well, the reason that works is because controllers are watching those URLs, and every time I put in a URL, that's an instruction to the controller or a request to the controller to figure out what to do. So, for example, when I first bring up the page, that fires off the home controller. And in the home controller are each of these actions to pull up the index page, the About page, and the Contact page, and each of these return views. The views are all the way over here in the Views folder, and you can see I've got in the Home folder an About view, a Contact view, and an Index view. So I don't actually request the views, I just put in a URL, the controller intercepts it, it understands what to do, and it's going to pull up these views, and it's going to put together any model information that needs to go in there. So for example, if I open up my Models folder, you'll notice I have this account model here. And this connects to a database, and this pulls up things like IDs and usernames, passwords. These things actually tie directly into the regular ASP.NET membership model. But here's what my model looks like for accounts. And when I pull up one of the account views, you'll notice I've got views for logging in, managing, registering, all this stuff. If I open up, say, the Register view, it's just some HTML with some MVC code. This is actually just display helpers. We can get to those in more detail, but these are just display helpers to help display things that come from the model. The controller sits in between these guys. Let me go up to the controller and open the account controller for you. And it's the controller that's actually doing things like figuring out, is the data valid when you log in? What do I do when somebody clicks the log off link? What do I do when I register? Notice here it's the controller telling it to create a user account, to log in, doing the redirecting. So you can kind of see that the controller is sort of the logical heartbeat for the things that a person is doing on the page. The view doesn't know about its data, and the data doesn't know about its view. And this provides us a very extensible and reusable way to create our application. And ultimately, we are using the stateless nature of the web to get it done. And so you'll notice that none of these views have a view state or anything that's going to be persistent from post to post. If you're going to go into ASP.NET MVC, you need to be able to make an educated decision between using MVC or using web forms. So I want to take a little bit of time and show you some of the key differences. Certainly not all, but some of the important ones. First of all, when we look at web forms, they use a view state to simulate a persistent state across web requests. In other words, for each web page, they're going to put in this encoded hidden field that helps preserve values between the times that you post the web form. So if I fill out a form and I hit the submit button and that page reloads, it can still have all my values in it because the web forms have put in this hidden field. It also uses controls to generate HTML on the fly. So when you're looking at web forms, you're going to see a little bit of HTML, a whole lot of web forms controls, and it's the server that's going to take those controls and convert them to HTML. And you don't really have a lot of control over how that happens. With web forms, the code and the UI are tightly coupled, at least by default. I mean, there's some engineering patterns you can use to get around this, but out of the box, the way most people develop using web forms, the controls you put on the page and the code that drives those controls are very tightly coupled. You've got the code in the code behind file. It's tied directly to the page, which is displaying those controls, and it's very hard to test those separately from each other. Web forms will also simulate a page lifecycle. So when you pull up a web form, it's going to have, for instance, a page load event. Each control is going to have a load event. The page is going to have a render event. There's all these different hooks into the page building itself that you can hook into. MVC, on the other hand, does not simulate a persistent state. The web by default is stateless. Web forms is a technology that tries to overcome that statelessness. MVC is a technology that tries to harness the statelessness. So it's two different ways of going about it. There's no hidden fields or anything in MVC that simulates a persistent state between page requests. MVC allows you to write the HTML. There aren't controls that convert themselves into HTML or concoct their own IDs or anything like that. With MVC, you supply all that. It's more work in a sense, but it's also a lot more control. The code is very strongly decoupled from the user interface. So views and models and controllers have no deliberate interdependentness between them. So if I modify the view very heavily, it's not going to break anything that's in my controller or in my model. Or if I change, say, my database very radically, it's not going to break my controller or my display. So this decoupling allows us a lot of testability and a lot of flexibility and extensibility as well. MVC does not have a page lifecycle. In virtually every respect, it behaves just like a regular HTML request. So there's no page load event, there's no initialize event, there's no pre-render. Now, there are events in the pipeline, in the server pipeline, that we can hook into with MVC, such as when a request comes in or a response goes out, and we can put some code there. But in terms of the page itself, the page does not have a life cycle and its own events. It doesn't have a post-back event. It doesn't have all that stuff that you normally hook code into when you're dealing with web forms. So let's take a look at a web forms project and an MVC project just to kind of draw these points of comparison out a little bit. What I'm going to be using is simply the default MVC application that Visual Studio provides and the default web forms application that Visual Studio provides. So it's nothing fancy at all, but it's enough to illustrate the differences between the two kinds of applications. What I'm looking at is default.aspx, which is the web forms application. You'll notice that each quote-unquote page in the application is its own .aspx file. So here we've got about.aspx, we've got default, we've got contact. Okay, so you can kind of drill into each of these pages and kind of see what they look like. The thing that I want to draw your attention to, though, is notice these controls. So here's the ASP content control. Here's the directive that binds these pages to the code behind. Each of these have their own code behind file. Some of them have a lot of code, some of them have hardly any. Here's the page lifecycle that you can see, so I can put code in here that ties to the page load event. Now if I look here in contact, a lot of these don't have any code in them because it's just the default application, but that's where we would put the code, is into those hooks. And if we had buttons to click, we would have routines that tied to those buttons in that code behind. Well, the thing is, if I wanted to write, say, an automated test for the default page, any code that I put in here, I can't just automatically unit test this. It's tied to the page. I need the page in order for this code to run. And so for some application developers that need a lot of testability or extensibility, this is something that they have to overcome. The other thing, too, is any control that I put on here is going to generate its own HTML, and I can't really control that HTML. So, for example, if I come here and I drag over just, any of these random controls, really, let's say I drag over a button. Okay, so now I've got this button in here, and I save this guy, and I fire him up. Oh, it doesn't like it because I put it outside the content control, right? So I can't just have it floating in there wherever I want. I actually have to drop it into one of these content controls. So let me drop that in there. Try it again. Okay. So here we've got my page. Here's that content control rendering its HTML. Okay, and here's my button. Now if I look at the source code on this and I look for that button, what I'm going to see is an input tag of type submit. So here's the body, here's the text, yada yada, and here's that button, input type submit. But what if I wanted to use, say, the button tag? Well, out of the box, I don't really have a choice. This is what I'm going to get no matter what. Now, sure, I can code extra layers where I override the button class, or I come up with my own control. There's all kinds of things I could do to work around it. But out of the box, this is what the button control is going to give me, and there's really nothing I can do about it. Now, this may be fine, but maybe it's not. You'll also notice that it generates its own cool little control name here, which might be useful for my JavaScript, might not. So there's all kinds of little things you have to deal with depending on how your application is going to operate. It's not bad, it's just you need to be aware of how Web Forms does things. And before I take off, notice here, of course, we've got the big view state, and the more controls we add, the bigger this view state is going to get. Now what this buys us, of course, is I can make these buttons do all kinds of things, and it can reload the page, and everything is going to be the same as it was before. That view state's going to remember all my values. So that does give me some programming functionality as well, but you trade off for it. MVC, on the other hand, I can pull up a very similar page. I'm going to make this my startup. And pull up a very similar page, but notice that when I view the source, there's no extra JavaScript, there's no HTML that I cannot control, there's no view state, there's no nothing. It's pretty much just the straight up HTML that I'm used to dealing with. And there's no code behind file for this either. What happens is when I put this URL in, I have a default controller that understands this means to go get any model that might apply to this view. In this case, there isn't any, and then serve up the view. So any code that's related to this page, I can test without having a page. I can unit test it very easily, and I control the output. So those are the kinds of things you want to look at when you're choosing between these two technologies. Do you need a technology that really helps simulate more of a desktop experience with forms that persist over time? Or do you need an architecture that allows you a lot of control over the output and a lot of ability to test and extend? Because if it's the latter, then MVC4 is probably your best choice. So what brought us to this point? I mean, Web Forms did a lot of things very well, and yes, there were some trade-offs, but those trade-offs are not insurmountable. What were some of the things that brought MVC into being? Well, there's four main things I want to look at. Probably the most important one is this idea of separation of concerns. And if you come from an object-oriented background, you're familiar with this, and it's the idea that each piece of code or each body of code needs to really only be concerned about its job and not everything else around it. The reason that we try to code this way is because A, it's a whole lot easier to test when code isn't tightly coupled to everything else around it, but also it makes code more reusable that way. If a code is a relatively self-contained unit that isn't concerned with 50 other jobs but just the one thing it does well, then we can easily reuse it, we can easily refactor it without it breaking anything else. In the Web Forms world, the code behind and the views are tightly coupled, but in the MVC world, we split them apart. So the separations of concerns was an important driver behind that. Another thing is the idea of convention over configuration. So when Microsoft made the MVC framework, what they wanted to do is make it so that you had to do as little plumbing as possible. So out of the box, as long as you follow certain naming conventions and put things in certain places, there's really not a whole lot you have to do to make MVC magically work. There are some things you can do, and you can still separate things and customize things. That's fine. But if you just want to use MVC out of the box, as long as you follow conventions, there's just not a whole lot you have to do to wire everything up. Keep it dry. Dry stands for don't repeat yourself, and it's sort of one of the cardinal sins of coding. We've probably all had the experience where we needed same or similar code to run somewhere else, so we just copied and pasted and maybe tweaked it a little bit and hoped that went okay. Well, we've all had that experience of trying to do it when we're trying to get something out the door in 5 minutes, but by and large, we also recognize that's not a great thing to do because now we have to maintain the code in 2 different places or 3 or 4 or 8 or however often you've repeated yourself. And the other thing is if we want to change that code, we've got a lot of places to change it. So by keeping it so that you have your code in one reusable place, your code is going to be a whole lot easier to refactor and a whole lot easier to maintain. So MVC allows us to do this because if I have code in the web forms world that say I want to be shared across 2 different pages, I got to do some engineering to make that happen. But in MVC, since the controller separates the logic from the view, then I can reuse the same logic for as many views as I want with hardly any work. And then finally, there's a strong tenet of MVC of being helpful but getting out of my way. In other words, MVC is going to facilitate things that I want to do, but it's not going to control a lot of things that I want to do. It's not going to write HTML for me. It's not going to change IDs. It's not going to inject JavaScript without me telling it to do that. So it provides me a true framework to develop on, but it's not going to be obtrusive. It's not going to do a lot of stuff for me. And some people might find that to be a liability, and that's fine. But for many developers, we consider this a strength because then it allows me to dictate exactly what I want the output to be and how I want the flow of the code and the control to go, and that's what we like. So some key issues in deciding between web forms as opposed to MVC, one is extensibility. How much extensibility do you actually need? I mean, if the web forms framework is good enough and you're not having to mess with the way the framework operates very much, then, there's no compelling reason to need all the extensibility that MVC brings you. But the extensibility features in MVC are very numerous, and they allow you to do all kinds of interesting things with security, authentication, logging, all kinds of things that sometimes can be a little bit painful to engineer in the web forms world. What about the blending of concerns? Does it bother you or does it matter to you that your code is tightly coupled to your views? If it doesn't matter to you, then why make an issue of it, right? But that's something you have to decide. If it's not an issue for you, then web forms might work great for you. If it is an issue for you, if you do a lot of unit testing or you do a lot of code reuse, then you might start looking at MVC. MVC uses methods, not files. Now, this is something that you're going to see over and over again as we talk about MVC. In the web forms framework, everything is based around the .aspx file. In MVC, it's all based around the URL. The URL fires methods of a controller, and those methods decide what view to use, what model to use, and they do all the assembly there. So you may have URLs that connect to no file whatsoever, but it tells the controller to do something. And that controller might be hitting a database, pulling out data, putting it in a view. It might, depending on your role, serve up one view over another view. The control really does a lot of those things. And so if a methods-based approach to developing your applications is going to be more useful for you, then MVC might be the way you go. Testability is a huge thing. How much are you actually writing tests and doing unit tests? I would highly recommend that you get into this world if you aren't already. It seriously minimizes the extra code that you have to write. It makes your designs better. It's just a great thing all around, as well as all the normal benefits you have of testing, like catching bugs early and having regression tests. If you're not really doing this, if those things are not concerns for you, web forms will probably do okay. But they are incredibly hard to unit test because you need the page to run the code behind. With MVC, you have no code behind, so it's incredibly easy to write tests around that code. Control over the HTML is also a big one. All these controls in web forms are going to generate HTML for you. And if you're okay with that HTML, then you're perfectly fine. A lot of people appreciate the ease with which they can build web pages out of web forms because they can just put the controls on there and let the controls worry about writing the HTML. But if you're the kind of developer or you're writing the kind of application where you really want or need control over the HTML, especially if you're using a lot of JavaScript, for example, to hook into that HTML, then MVC might be a better choice. There's a reason why you see a lot of mobile app developers, for example, kind of heading more toward the MVC world, because they're doing a lot with JavaScript and they're doing a lot that interacts with the client side. And it's a little bit easier to do that when you have control over the HTML that's being produced as opposed to not being entirely sure. Now finally, and this is kind of an interesting point, MVC, the MVC framework in Microsoft, is actually open source. You can actually download all the code for the MVC framework and look at it or change it. You could write your own MVC framework or take theirs and tweak it for your needs. So you have really unlimited control over how the MVC framework is going to work for you. Web Forms does not give you that control. Now the question is whether or not you need it. I mean, the Web Forms engine is a boxed solution that you can use from day one. You may not need any more control than that, and that's great. But if you do, if that's an issue for you where you want to be able to change the way your web pages are served up, then MVC is a great choice for you because you can modify that code to your heart's content.